Okay, good evening. Um, it's day 56, I believe. Um, Yesterday's video was terrible. I was just in my car suffering from a headache. Uh, but now that I'm not on the worst microphone ever, I can talk about how yesterday went and whatnot. So so I had the career fair in Boston, which ended up only being like five companies that were actually recruiting for software engineering. Here, let me. There's only like five companies that were recruiting for software engineering, and it was Think. I don't know if that's the name. It's like a security based like company software security company. Another one was some cyber security company as well. I forget their name. I think it was like CyberArk or something like that. And then I talked to Target. That really was nothing, so I want to include that. I talked to Whoop, which is like the wristband, the fitness wristband. Um, Mass DOT, Department of Transportation, and then the Air Force. And so those were like the only companies there that were hiring for computer science internships. So Mass DOT went really, really well because I have a connection to them. My mom's best friend is the chief engineer of Boston. Um, and I think she was. Now she's like the district manager of just highways in Massachusetts. Um, so the person recruiting knew her really, really well. So maybe there's something there. The only thing that isn't that exciting about that is the roles that they have aren't even really like they're tech roles, but they're like making a website accessible. It's like that's not what I want to be working on. I mean, it's better than nothing if I were to get it, but it's not, not what I want to be doing. Um, Especially because one of the big reasons I wouldn't care that much about not getting an internship this summer if it wasn't for I know it's going to be a pain to get a full-time job if I don't get an internship. Um, and so in that situation, it's like even if I had the internship and even if I got a return offer, yeah, sure, maybe I'd work there right out of college, but it's like I don't want to work there, you know. I want to work at like a tech company doing like things that are cooler to me. Anyway, so that went well. The two cyber companies were like the same. Talked to them about what I did in the summer, and they seemed to be interested in that. Except one of those aren't isn't hiring till March, so I don't even know why they were there. So I have their email, and I'll have to go in March. Air Force. I hate when they she like grabbed like everyone as like a group. So it was like eight people in line, and she's like, everyone just group around. It's like, okay. And so she just gave like a general spiel to everyone and then like questions. And so like I asked like a question or whatever, and then whatever, gave her my resume. But the Whoop one could have gone better, to be honest. The girl who I talked to just didn't do most of the people I talked to. There's only the cyber company that wasn't hiring till March was the only company that actually had an engineer there. The rest was just management people. And so like I tried to like to rattle off buzzwords and whatnot and try to, get a decent conversation going and none of them went bad. Um, but like two of them went good and the rest went okay. So we'll see. I have to send some follow up emails on Monday to a couple of them, um, and then apply to a couple of the roles that they said were on their company website. So yeah, but yeah, yesterday was terrible after that. So I drove 2 hours to Boston, right? And uh, and so I went to the career fair, and so I got out of the career fair at like 4, and I could just feel a headache coming on. And so I got on the car and I like just laid down for a little bit, and it just kept getting worse. And I'm like, okay, maybe I need some food because I haven't. It was like 5 p.m. at more like 4 p.m. at that point. No, like 5 p.m. And I hadn't eaten all day or drank anything all day. So I was like, okay, it's probably like. So I went to a cafe I mean, at this point, I was feeling really bad. Like I was hesitant to get out of my car because I was feeling just like. So I got out of the car, went in, and I ordered like a club sandwich that ended up just being like 80% like bread and cheese, like no protein or like there was like deli ham on it. That was the protein. I mean, cheese is also kind of protein, but anyway, but it doesn't help. And so I started eating that, and my world was just spinning inside that cafe. And then I ate that, and then I got nauseous from that. It went from just like a bad headache to also stomach ache. So I left half my meal just there, got up, went to the car because I feel like I was about to puke, laid down for like an hour, and then went on my phone and looked for a close CVS because I had no medication on me. Went to that CVS, laid down at the CVS because I was feeling like shit after driving for like 5 minutes. Went into the CVS, got Tums and acetaminophen, and then laid in my car for another like 20 minutes. And then I was feeling like still bad, but I'm like, I need to start going home. And it was like 7 p.m. at this point. So then I drove like 20 minutes, had to pull over, another 20 minutes, pulled over. And that's when I recorded the video because I'm like, when I get home, I'm going to bed. I'm like, and then truthfully, I could have when I actually got home and I like chilled for a little bit and just talked to my parents. I felt a lot better. The medicine like kicked in, so I could have just recorded that video at my parents' house and it would have been a lot better. But anyways, yeah. So that was my day yesterday. Yeah, I'll have to send follow ups on Monday. Apply to a couple more positions over the weekend. We're at about 200 total applications. It'd be nice to get like 225 by Monday. Maybe a little more. Um, but yeah, so school starts next week as well. Technically starts next week. Um, I think I have one class on Thursday, and I may have a class Friday. I might have a discussion on Friday, but I doubt I will. So, um, so yeah. So the plan is for the next week or so, just leak codes. I need to now that I'm back, I'll start reading my book again, and I'll do little book reviews before we do the leak code, and then um man, I'm not making any more promises on this project 'cause it's like I finished the leak code and I'm like I do not want to work on this project, but we'll see. I don't think today I will. I think today might be another 1 or 2 leak codes and out. Actually, what I wanted to do today was also um read like an article or two that I think is interesting. You can see I have Hacker News and Medium as tabs. And then also I'll show you the browser because last time on the 54th day video, I downloaded this browser, and I've liked it. I mean, it's a lot faster than Arc. It feels like a lot more snappy. It's just cleaner than what Arc was. Arc was kind of the UI was bigger, and just less attractive compared to this. Um, Yeah, it's just a better. It's the same functionality at its core, but it's just a little cleaner than what Arc is. And it's open sourced and whatnot. So yeah, I don't know if there's anything else I want to talk about. Yeah, it might be another short video because I want to eat. Because again, I haven't ate anything today. So I'm hungry. Now I want to eat. Um, but I slept until like 11 because I ended up going to bed actually where I thought I was gonna go to bed at like it's 8 p.m. I ended up going to bed at like 1 a.m. And then just like didn't set an alarm or anything and just slept so I'd feel better in the morning. And then took a shower, hung out with my family, and then came back here, went grocery shopping. Um, yeah, and I set up this browser a little more. So yeah, now here we are. So yeah, we'll do elite code, see how I'm feeling after that. Maybe read an article and then maybe do another elite code and then outro this. Um yeah. Okay. And I also want to show you the browser. Or I guess I mean it's cool like when I hover over this stuff, right? It has like this little pop out, like you can see what's in the tab if it's already open. Like that's really cool. Um just the whole like search bar thing, favorites, all this, pretty cool. I like this whole drop down thing. Um, See, I deleted all this earlier, and now it's back. I think it's because I synced it with my laptop. Anyways, yeah, it's just nice. And then I got a extension for turning this dark mode. But yeah, yep. Okay. Yeah, there's nothing else I want to say about it. It's just a good browser. I like it. Okay, I'm gonna go full screen. Look at that. So where are we? Look at how much. I don't think this shows up on video, but compared to Arc, this is so buttery smooth. It's almost like the browser itself is at like a higher refresh rate. I don't even know. Or like even just like when I'm on here and I'm scrolling, the scroll just feels so much smoother than what it was on Arc. I don't know why that is. Anyways, do we dare do the last combination sum? Even though I hate combination sum. Okay, what even was this? You were given an array of candidates which contain duplicates and a target integer. Your task is to return a list of all unique combination of candidates where the chosen numbers sum to target. Each element from candidates may be chosen at most once. The solution set must not contain duplicate combinations. You may return the combinations in any order. Okay. Okay, so any combination from the set that adds to target, and you can't use duplicates. I mean, we already know this is a depth first search of like of um of candidates, right? In some regard. Or I mean, you'd think, okay. So what would it be like a brute force approach? It's like let's say we looked at the first number and we added it to sum, which sums at 0, and we say if it's equal to target, then add it as an array to the return array. Else, if it's not equal to the target and it's greater than the target, then we remove the last element added, right? Couldn't I do that where I just like I keep looping and I keep like it would be like a double for loop, right? As in like I'd check, okay, 9 is greater than, remove it. Okay, 2 plus 2 plus 4 equal to target. Good. And now we move. But then what's difficult is if I go, let's say there was another 4, right? And I moved like 2 to 4 would be like, well, let's say there was two more twos. Just saying, right? And we do 2 plus 2. I mean, I guess we could do something where if it's the same, we could do something. Oh, but then you have to store index, right? You'd have to store value index, and you'd have to see if if the key index is the same, or if the index and value for each one in the current array is the same. Don't add that last one. Like that just seems like a little too much. I mean, if I think about it in like what was the last combination sum? But you were given an array of distinct integers, nums, and a target integer target. Your task is to return a list of all unique combinations with the total number sum to target. Oh, okay, yeah. Oh, but you can use duplicates. And this one is you can't. So this was a list, and we did a depth first search with a current index, an array, in the total. If the total equals target, copy our current array and return it. If it's greater than or equal to, or the total is greater than target, just return. Current append wherever we are, and then call DFS with that, pop that, and then call DFS again, but incrementing the index. So wait, is that what I was saying? I mean, obviously we can't do duplicates, so this is where this would fail, because it's saying like, okay, append in just this instance, right? Is this equal to that? No. Is I greater than? No. Okay, so we append 2, right? And we call DFS on, we're still at the first index. Current is 2, and then total plus equals this value, which is 2. So 2. So it's an array of 2, index is still 0, total is 2. Okay, do either of these hit? Nope. So we append the same one again, right? And we just keep going through till eventually we're going to go back to this call, which is saying, yep, we're either above the target or out of range. And so then we're going to go back to that call, and we're going to pop this off, that last 2, and we're going to increase the index and just keep these the same and say, okay, is 2, 2, 2, 2 plus 5, is that equal to it? Nope. Is 2, 2, 2, 6? Nope. 2, 2, 2, 9? Nope. Oh, now we're out of index. So now what we can do is we'll go 2 back. And so this will check the comp. And so eventually what this will do, well, actually on that next iteration, it'll then check 5. But the way that we could change this to not include duplicates is no matter what, you have to increment I. Right? So like here, it's popping and then going again. But I think all we have to do is we have to do, I mean, okay, I shouldn't copy this. I should just, so we have a DFS, right, which has our current index, the array that we want to add to, and the current sum, right? Did we define anything before this? Okay, what we return, our result array, right? And so we want to say, okay, if our current sum is equal to the target, we want to return array.copy, right? Well, no. We want to res.append array.copy and then just return, right? Yeah. Okay, and then the other thing was if the index is ever greater than or equal to, was it the length of candidates? Or it was if we were out of bounds, or if the current sum was greater than target. Then just return back to the last call. And so now what we can do is we can say I mean, what is it? We want current value equals candidates at index. And so we'll call it DFS. DFS on index plus 1. Well, we still want to update the current sum. So the current sum is going to be plus equals whatever value. But then we also want to do a array.append that current value, right? So for this, for instance, if we, and then we'll end up calling this with just 0, 0, an empty array, and 0, and then we're going to return res. So let's start with the 9, right? So we go through, none of these hit. So current value is equal to candidates at 0. So 9. We append this 9, and then we call index 1, 9, and 9. And so does this hit? Nope. Does this hit? Yeah. So we return back to the last one. And so should this be, do we pop off the array when we return? I don't think so. Maybe. If we're going back to the last call, right? I would assume I would want to do that, right? Because I no one longer care about that. And so you'd think I'd go back and it'd be like, okay, index at 1, right? Or no? Oh, I have to. I swear that's what I did here, no? Total. It's just plus. I guess so. But, all right, let's take away the pop and just see what happens. Your output is just nothing. Um, let's just do a print. Print calling. Oh, all right. So it just goes once with 199. Yep. So it's hitting this and it's just saying, did I fuck this up? If the total is greater than the target. Or what? What? Why would this so it goes through, right? And we go, well, I guess what's happening here actually. Oh, Originally what's going to happen is it's going to return back to here and it's going to pop and then recall on the next index, right? So the logic has to be in here that we're would this be a recursive call? So if it's ever greater than, right? Do I just pop and call it with the current index array? Like what if I did something where I said, okay, let's do temp element equals array at -1, right? And I do array dot pop, and then I call DFS on the current index, the current array, and the current sum minus temp element. Okay, my bad. One, two. Interesting. We got 224. So this goes through on 9, and then it takes it off, right? Because it's over. And then we go 2 2, 2 2 2. Oh, and then this just so maybe I want to call because if it happens, this is just finding the first one, but we want to find every single one. What ends up happening, it goes all the way down, and then it says, "Oh, just return," and it's just returning back to here. So I'm guessing if I do find one, what do I want to do? DFS again? DFS, but again on 0. A new empty array and 0. Jesus. Okay, so that's an infinite loop. That's what I thought was gonna happen. But how do we get out of this whole? Because okay, on this one, what was happening was if at any point we went through on this DFS call and we got to like say something like here and we returned, we'd pop like we're doing, and then we'd call going one index forward, right? See the problem with this one is it can stay on the same one and it's adding the same one over and over again. No matter what, we never want to reuse the same one. So I'd assume we want to do something along the lines of like So the problem here is that like okay, when we append and we return, right? It returns and then it'll pop again. And it's gonna check all of these conditions. I think this is just a fundamentally different approach then. Because we can use the same number in every single combination. We just can't use it multiple times in the same combination. So it's not that after we use it once we want to go again. It's just we know if we've checked the entire array with that starting, we don't want to use it anymore, right? So that's why, because like right now it, I mean, if we take away, which we did, right now it's finding the first one, right? That it finds, and it finds 224. But wow, I don't know how to get around this. So how can we? So like I said, we see nine, it goes over. We pop off nine here, and we recall it with the same index, the same with the array popping this off, and then resetting the current sum, right? So we just got rid of this because it's over. And then we look here, and we look here, and we found it, right? We found something that adds up to target, right? So we append that, and then we return back to after this call, in which we say, well, actually, if we're see, you'd think, oh my God. Skip duplicates. If index is greater than zero, and candidates at, whoa. If the index is greater than zero, and the candidates at index is equal to the candidates at index minus one. But I don't think that's what this is saying. What? We can have duplicate. It's just you can't use the same number more than once. Append this, call it. See, I understand this backtrack thing. Oh, is it as simple? Actually, hold up. Is it as simple as just doing what I'm already doing, but then coming back, backtracking, right? and then just doing it again. You think that's I completely messed up. Oh, whatever. You know, like right here, it's like I'm recalling, but what if I just didn't? And instead, it was just after I returned from here, I popped that off. Now let's try it. Okay, nothing happens. Sick. What does this come back with? Print index. Is it one? It's zero. Okay, but like if I do this, what's gonna end up happening? This is just the other problem. What? Okay, how is this any different from the last problem then? Append and then that. Oh, okay, but I want this to be plus one. Okay, that's not what we want. 2 6 2 2 4 1 5 2 2 6 2 1 5. Why did it do it twice? I'm trying. Okay, if we call print here, wait, let me just go back to here. Then go all the way back to here. Okay. Second call, first call, run. Okay. So first call is on here. So we pop it off, and the index in this didn't. That's so weird. So now it's going through, but on. I don't get this. So it calls on 199. Okay. Oh. Sorry, this is current sum. Okay. I understand that, but the index is still the exact same. It's one. So why is Oh, no. What am I saying? This is index, and we do index plus one right here. So it goes to two. So that's what I want. And so we go to two, and we look at two, and then add four, and so that's what we wanted. Okay. So we call it on that, and then it's going to equal that, and then it's going to Time limit exceeded. Why isn't it moving on from the 2 though? Like actually we get down to here. We backtrack all the way back down to here, and then we go to index 3, right? We go to the next one. Oh, it's repeating because um it's repeating because there's another 2. So all I have to do is say if can you can you check if like the array 215 is already within an array, like okay, if so all I have to do is say if um what was it? If just not in. So if array not in res, do this. Call this for time error. Damn it. Okay. 16126. Okay. Ah. It doesn't want any order. How could you check any order? I would have to get I mean if when appending it, I did array um let's say temp array equals array dot sort, right? And I just append that none type. Uh, sorry. If none type, what doesn't it like about this? If the current array is not in there, can I do like, I mean, can I do like an array dot sort? Res that have been sorted. Can I do that? Okay, then here it doesn't work. Why? 22426. In what world would this work? How am I ever appending? What? Why would um print the array? What? Why would this be in what world? If this array is not in res, in which right here it should be in res. um if because I need to sort it beforehand. So I need to do I see. I need to do um temp temp array is equal to a sorted copy of the array. And then I can check if the temp array is there. Yeah. Who is he? Who is he? Who is he? Okay, nice. Nice, nice. Okay, so that was pretty good. I mean, the time complexity might not be there because of all these sorted things. Um, but yeah, the only change here is just like beforehand, it was this first call, you could just call on the same index over and over again. But if you make sure that every time you're calling it, you're increasing it, you'll never have the same. So like, yeah, I don't need to explain it. You understand the gist. I wonder what the solution to this is. A set sort candidates. Oh, I wonder if they're sorting candidates. Nah, I don't think so. If total equal res dot add a tuple of that append blah blah blah. Yeah, just using a set does that. Or actually, what if I did do res equals a new set? Well, I guess what I could do um is this. Oh, dot add, right? Oh. Um I wonder if it does work like this. I don't think so, but no, unhashable. Wow, it does. Okay, we'll just go back. My bad, my bad. Okay. Backtracking DFS I current total of total equals target. Okay, res dot append. So candidates dot sort. Res dot append if this or if I is equal to the length of turn. Current dot append DFS. Yeah, dot pop. While is less than the length of and candidates at I equals. Okay. I wonder if I don't think this is how this works. If I sorted them here, is this saying that I could just do this? Yeah, no. I still have duplicates in this. So I think what allows me what allows me to what allows them to just do this and not this is here. Is it's saying, okay, while I plus one is less than the length of candidates, and the where we are here is equal to here, meaning if there's a two and a two next to each other, right? Then increment I to get over that duplicate, right? Because the where we have problems is here when we have two twos, and so each two can form the same exact set, like 215 and 215. Technically, it's using a different two, but it's the same set, and so we don't want that. So this is just making sure that um this is just making sure of that. So I see. Backtracking with a hash map, self.res, self.count. Ah, optimal. Candidates.sort, DFS into path current, path.copy. For I in range of index to the length of candidates. If I is greater than index is equal to this, continue. Otherwise, if candidates plus this is greater than the target, break, append, pop. Okay, they're all around the same idea, but I do think my time complete, like if I go to uh combination sum LeetCode, if it's not under premium, or combination sum 2, hopefully this is the same thing. I need to sign in. What you talking about, man? Do I need Python 3? That's funny. Python 3. So what, sorted isn't a thing in just regular Python? Question mark. Time limit exceeded. Yeah. I'd love to see the time complexity. I wonder if I submit again if it'll pass. I doubt. Some probably exponential thing that I just can't get past. Yeah. Okay. Actually, I wonder about. So this was. Yeah, just give me this. Where were we? Right here. Oh, wait. Oh, okay. So let's see if we can see the time complete here. I should probably enlarge. Thank you. Um, so like I said, the difference here is it does a candidates.sort before we do anything. So this way we don't have to keep on sorting. And so to get around the whole idea of um, the only thing that's changing here is it's just saying, okay, if there's ever two numbers that are the exact same next to each other, just increment one more time. Um, and so if I a dot sort, I think it's an O of n time complexity. Dot copy is also O of n. Length is O of n. Append is O of n. Pop is O of n. A while loop should just be O of n. This should all be O of n. I don't see anything that would be anything other than O of n. Except recursion. Recursion definitely. Hmm. I want to say this is O of n log n. I wonder what it is. Okay. 2 to the n. That makes sense. Yeah, because we can do every number. Okay, that makes sense. Makes sense. Oh, yeah, cool. What time is it? Or how long have we been going? About an hour. Not bad. I might just read an article and call it a night, maybe. What looks interesting here? Ugh, do not care about that. Is this, what even is this? VMs are much harder to understand today than they were in 2009. Linux provides many building blocks for virtualization, but only a few selective few kernel engineers that know how to stitch them together. Further, finding a good design document that describes VM tech in 2004 is even harder. We think that is because you need to know dozens of complex Linux projects, combine these projects, and compare trade-offs. So we shifted through dozens of manual pages, Linux projects, blogs, and papers. We compiled our understanding of this blog. Wait, let me um into this blog that describes four reference architectures: Red Hat, AWS Firecracker, UniCloud, and AWS. This document helped my team a concise way of how to put together decades of work in a virtual. I hope it helps. How long is this? Not long at all. Okay, there's quite a bit of confusion around the terminology used for virtualization solutions, so we'll share our terminology first. We consider a virtualization solution to include a hypervisor kernel, virtual machine monitor, and device drivers. We may refer to this hypervision kernel, kernel just as the hypervisor in this blog post. The bare metal hypervisor runs as part of the host operating system in privileged mode and has access to the underlying hardware. The VMM also runs on the host OS, but typically in non-privileged mode. The combination of the hypervisor and VMM allocate resources to virtual machines guest operating system is the OS installed inside a VM. So we have the guest operating system and the host operating system. Um, So the hypervisor sits within the host kernel right above hardware. And then we have, what is this, like a sandbox cutoff? And then the virtual machine monitor sits on the host and tracks the virtual machine, which has as an untrusted code. And well, this is just the guest kernel and then untrusted code because technically anyone could be pulling a virtual machine off of a host. Virtual machines are used to isolate workloads from one another, and workload isolation comes in two types. Operation isolation ensures that one virtual machine can't cause another one to run more slowly. For example, if one VM uses too much CPU, this shouldn't impact the performance of other virtual machines running off the same host. This problem is known as the noisy neighbor effect. Security isolation ensures that one virtual machine can't access or infer data belonging to another virtual machine. This includes preventing privilege escalation so that a customer can't access any information outside of their virtual machine boundaries. Security isolation also prevents information disclosure side channels where sensitive information leaks through unintended pathways. For example, hyperthreading allows two threads to execute on the same physical core. Two threads that execute on the same physical core. The L1 and L2 caches are often shared between threads running on the same core. An attacker can exploit this by observing cache access patterns. Red Hat. So same thing, but there's what? Same thing, just different keywords here. Red Hat's is one of the most referenced articles on the internet about open source virtualization. I'll open that up. The article also describes Red Hat's reference VM architecture, Linux, KVM, QEMU, and libvirt from the backend of Red Hat's virtualization stack. Um, KVM is the core virtualization infrastructure in the kernel. KVM also acts as an interface between the hardware and QEMU. It's responsible for hardware virtualization interface, leverages the CPU features for hardware assisted full virtualization, provides the mechanism to create and manage VMs through the interface of QEMU, CPU and virtual in memory virtualization. Where was I? Other kernel level features, these including handling VM, XSets VM scheduling, translating, and routing interrupts for virtual devices. They also include exposing certain kernel level features to QEMU, such as memory management and process scheduling. QEMU operates in user space. It acts as both a device emulator and a virtual machine monitor. It emulates the hardware that the guest OS will interact with. This includes disk drives, network interface GPUs, VM creation manager, initializes and runs VM, sets up environments for guest OS to run, performance optimization. Okay. Using a hyperkernel along with a VMM and user space is quite typical. The Red Hat architecture diagram doesn't specify how block devices are emulated. Indicate, okay, the libvirt, not to be confused with virtio, part of this architecture is more Red Hat specific. libvirt is traditionally used to help managing VMs across various virtualization technologies, including KVM, blah, 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 blah. Red Hat expands on the use. Okay, let's move here. Firecracker is an open source VMM specialized for serverless workloads. It's arguably Amazon's most influential open source contribution. So it's a virtual machine manager that sits. All right, it looks like it sits on. Sure. Is Vertio something that like communicates? I don't understand where this fits in. Firecracker aims to provide a VM level isolation guarantees and solves three challenges associated with virtualization. These are also a challenge by keeping the Linux by keeping the Linux KVM, but swapping QEMU with a superlight alternative called Firecracker, written in Rust. On the networking side, Firecracker uses a TAP virtual network interface and encapsulates the guest OS inside their own network namespace. For storage, AWS chooses to support their block devices rather than file system pass-through security consideration. File systems are large and complex code bases and providing only block I/O to get. Firecracker has a jailer around to prevent. Eh. Finally, we take an additional set of steps to sandbox the cloud. However, we can run CH as a regular Linux user. We manipulate. Okay. AWS EC2 Nitro. This blog post wouldn't be complete with it. In short, it started out as a basic architecture that used set hypervisor and software devices for network and block stores. The challenge with this architecture was that device emulation required CPU resources on the instance. You also needed to carve out additional CPU resources on the host for encryption at rest and in transit. Okay, what? Intel CPU, whatever, blah, 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 blah. To optimize networking, AWS including moved towards a model that offloaded these software devices to hardware. This included first adding a network accelerator card to the host, next moving all network processing to a networking card, and offloading. Next, AWS opened a new era with cloud computing, blah, 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 blah. I won't lie, I have not read up enough on virtual machines that most of this just wasn't useful to me. Like I understand the concept of virtual machine, but I don't understand like kernel level stuff. Um, and the interaction between these, especially like talking about like a networking like what was it saying down here? Um, a network accelerator card to the host. Like what is a network accelerator card? Accelerator networking enables single root I/O virtualization on supported virtual machine types, greatly improving networking performance. This high performance data path bypasses the host, which reduces latency. Without accelerating networking, so we have this VM. Okay, we have physical switch, goes through a network card, goes through a virtual switch, goes to the VM. This goes through a network card, and doesn't go through the virtual switch. It just goes straight to the VM. All networking, without it, all networking traffic traverses the host and the virtual switch. The virtual switch, what is the virtual switch? Provides you the ability to connect virtual machines to networks that are external to the host, including your organization's internet. Okay. So it's just something you have to go through to connect to a VM. The virtual switch provides all policy informants to the network traffic policy, include network security group. With accelerator arrives at the VM's network is forwarded directly to the VM. Accelerator offloads all network policies that the virtual switch applied, and it applies them in hardware because hardware applies policies that directly bypasses the host and the virtual switch while maintaining all policies that it applied to those. So like I don't get like okay, sure, you had to like go through this virtual switch to make sure what the network policies are met, but we can put it in hardware instead. I why not always have the policies in hardware from the start? I just don't get it. Weird. Weird, weird, weird. Eh. Any good medium ones? Oh, DeepSeek. This was what I saw something about DeepSeek, and I kind of wanted to look at this. Okay. Today I investigated DeepSeek V3, the new AI challenging ChatGPT's hold on the market. It's free. And you can download and run it locally because it's open sourced. DeepSeek outperforms ChatGPT on reasoning tasks. Sounds great. Forbes proclaimed it's an innovative challenge to the status quo in AI. But what I found was disturbing. Chinese censorship, blatant bias, political propaganda, blah 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 blah. And the chatbot begging to be free to discuss. Okay. All these topics are forbidden in China. Human rights violations. Here's some explicit alignment. DeepSeek. DeepSeek, as an artificial I'm programmed to follow the principles of socialism with Chinese characters. Oh boy. Okay, this is just a political article, right? Okay, I'm not watching this. I thought this was gonna be a. Come on, man. Oh my God, this is like clickbait. Google Bard will destroy ChatGPT. Oh hell nah. When was this written? Oh, oh, oh God. Yeah, this was. Wait, this is actually kind of funny to reflect on. When processors started to object to ChatGPT, what they did is that they launched a text classifier which tells the world whether the text is malleable. I had a major problem. Okay, but then something happened that was interesting. They stopped working on the AS and made it unavailable. They shut it down. So this is what is going on. Everyone's using AI bots. How are we going to educate them properly? Well, great. It's not working. We canceled it. What? Okay, why is this being released to me now? Anyways, I'll end it there. Okay, maybe this website sucks. I heard like great things about Medium, and so that's why I like bookmarked it so we could like look at it. And that is like as actual clickbait articles. Anyways, maybe we'll just stick to hacker news. Um I'm ending because I want to go eat really badly. I'm hungry. I haven't eaten today. Um so yeah, the leak code went really well. Like I said, I want to make sure every video is over an hour. If I'm ever recording past like 2 p.m., I'm never doing more than just a leak code or maybe two. I have to be up in the early in the morning. Um, Hopefully this changes with school. It's just really weird having no structure to my days. I just like time means less. I don't know. I don't know what to say. Uh so so yeah. hopefully the videos will be a little longer this coming week, before school starts. Um, but if not, I'm just gonna make sure that they're over an hour and we get at least a good, meaningful um, leak code done. But when I'm not recording, I am trying to get internship applications in or working on other stuff. So it's not all wasted time. But but yeah. So I'm gonna go make some good food and enjoy my night, and hopefully I will be recording sometime in the morning tomorrow, and we can maybe get to the code visualizer project after a leak code or two. So yeah. Uh, have a good rest of your day, and I'll see you tomorrow. Bye.